E, my favorite number. The number E is also known as Euler's number, after the mathematician Leonhard Euler. It's found by computing the following infinite sums. You do not need to know how to compute infinite sums right now. You'll learn how to do that in calculus. But it's the sum of 1 plus 1 plus 1 over n factorial for n as n approaches infinity. It's an irrational constant, like pi, and it's approximately equal to 2.718. It's also sometimes called the natural base, and it's important in a lot of different functions. Y equals e to the x is one of the most important exponential functions. So you've got an E button right here on your calculator, or if you are raising it to an exponent, you've got an e to the exponent button right here that you can hit instead of having to hit the little caret. Saves you a button press. This is one of my favorite comics. This is true. This is called Euler's identity. E to the pi times I is equal to -1. No, it will not be on a test. Swiss entomologist Dr. Paul Mueller was awarded the Nobel Prize in Medicine in 1948 for his work with the pesticide DDT. Dr. Mueller discovered that DDT is effective against insects that destroy agricultural crops, mosquitoes that transmit malaria and yellow fever, as well as lice that carry typhus. It was later discovered that DDT presented a risk to humans. Effective January 1st, 1973, the United States Environmental Protection Agency banned all uses of DDT. More than 1 times 10 to the 10th kilograms of DDT had been used in the U.S. before the ban. How much will remain in the environment in 2025? DDT degrades into harmless materials over time. To find the amount of substance that decays exponentially remaining after a certain amount of time, you can use the following formula for exponential growth or decay, which involves the number e. So this looks very similar to the exponential growth and decay function that we learned in the previous section. We have n equals n0, that's our initial amount, but instead of 1 plus some growth rate, we have the number e to the kt. T is the amount of time, and k is a constant affecting the growth rate. K will usually be given to you unless you need to solve it. So assume that there were 1 times 10 to the 10th kilograms of DDT in the environment in 1973, and that for DDT, K is equal to -0.211. Write a function to model the amount of DDT remaining in the environment. So n equals n0, which is 1 times 10 to the 10th, times e to the k, which is -0.0211, times t. So this is our function for the amount of DDT in the environment. If we are going to find the amount remaining in the environment in 2025, we need t to be the years since 1973, which is going to be 52 years. So if t equals 52, we do 1 times 10 to the 10th times e to the -0.0211 times 52. And if we plug that into our calculator, to the -0.0211 times 52, and we get a very large number. I come up with 1, 2, 3, 4, 5, 6, 7, 8, 9. So I come up with this, which is 3,338,044,288 kilograms of DDT. We can also use E in compound interest. There's a version of our compound interest formula called continuously compounded interest. Continuously compounded interest, as soon as you are earning interest, that interest goes into your account and starts earning more interest. So the equation for continuously compounded interest is A equals PE to the RT, where just like in the previous compounded interest formula, P is your principal or your initial amount, A is the final amount, R is your interest rate, and T is the time in years. So compare the balance after 25 years of a $10,000 investment earning 6.75% interest compounded continuously to the same investment compounded semi-annually. So let's do the semi-annual one first, right? This is P1 plus R over N to the NT. And so our principal is $10,000. Our interest rate is 0.0675. Compounded semi-annually means that our N is equal to 2, and we are doing it for 25 years. And so when we plug all of that into the calculator, 1 plus 0.0675 over 2 to the 2 times 25. Plug all that into the calculator and come up with $52,574.62. Now, what about the compound interest? So now we have that same $10,000 principal. Instead of our 1 plus R over N, we're going to use E to the R 0.0675 T. So 10,000 times E to the 0.0675 times 25. Our T here was 25. And that ends up being $54,059.49. So, almost $1,500 more. Start same amount, same principal, same interest rate, same amount of time, but we get almost $1,500 more just by changing the amount of times that it is compounded, the frequency that is compounded. And that's it for the number E. Next time, logarithmic functions.